And we looked at a way to make it go around counterclockwise. We looked at a way for it to go around faster in less time if the parameter can also be interpreted as time. But it turns out we can do a lot of other things. For example, we could choose to have the center be anywhere. So instead of 0, 0, I could tweak this and say, well, let's try a center of 3, 4. And instead of having a radius of 1, we could try a radius of 5. So if I want the center to be 3, 4 instead, I would just shift x by 3 and y by 4. And if I wanted the radius to be 5, I would just multiply cosine by 5 and multiply sine by 5. So I think if I were to then graph x equals 3 plus 5 cosine t, and y equals 4 plus 5 sine t, I should get this particular circle. Seem reasonable? Yeah. Now, again, I have lots of ideas that seem reasonable, and then in practice they're not. So I'm just going to run over to Desmos and say, hey, what do you think about this? So here I'm going to drop in x equals 3 for the center, and then I want to use the cosine to move around that for the radius of 5. And then here I've set it up to use x as the initial parameter. And then for y, the g function, I want to have y equals 4 as the center, and then use 5 sine to move around that. And it should make a full circle based on the unit circle idea if I go up to 2 pi, which is a little over 6. Far enough. Let's just move you down and see, does really look like I have a radius of 5. So I'm going from -2 to 8, which is 10 across. Half of that is 5. That looks reasonable. The center seems to be about here, which looks to be about 3, 4. It looks like that worked okay. And this is being traced counterclockwise. We take the parameter back to 0. All right, that wasn't too bad. All right, let's try another one. Suppose instead of a circle, I wanted an ellipse. Like I wanted to stretch this out horizontally. Well, since I have control here of x and y, why not just choose a different radius in one direction? What happens if I let the x radius be bigger than the y radius? And actually, I want to go to a simpler version of that. So I want to go back to 0, 0. So I'm curious. What if I took center 0, 0, but I have a radius in the x direction of, say, 6, and a radius in the y direction of, let's say, 4? So I want to try the parameterization x equals 6 cosine of t, and y equals 4 sine of t. So I think what this will do is the maximum distance I can move away from the origin in the y direction is 4, and the maximum distance we can move in the x direction should be 6, and so I should get something that looks like an oval or an ellipse. I'm going to do a rough sketch and then go over to Desmos. So let's see, let's make here-ish. The other axis, so I think that's 4 up there, -4 down there, 6 would be here, -6 would be there. I should get something that's not quite circular, oval-ish. Looks like I miscounted in one direction. 3, 5, oops, 6 is supposed to be there. So more like that. And I think this right here is where t will be 0 and it will trace in a counterclockwise direction. All right, let's give it a try. So tweak, get rid of that. That. Hey, yeah, that's what it looks like. Cool. Okay, so the question is, what shape is this actually? Is it really an ellipse? Well, here's how I'm going to figure that out. Back here, I use the idea of a circle to get this. And specifically, I started thinking about the unit circle, and the unit circle has x squared plus y squared equals 1. Now here I've made it a bit more complicated. I do know this though. As far as sine and cosine, which I'm using, I know that the cosine squared of some angle, cosine, that's supposed to be a t, plus the sine squared of that same angle has to be 1. Well, I can solve each of these for cosine and sine. So according to this one right here, the cosine of t is equal to x over 6. And this one right here says if I solve for the sine of t would be y over 4. So I can just substitute these into the Pythagorean identity. If I do that, then I'm going to get parentheses x over, oops, that's not next, try again. X over 6 parentheses squared plus parentheses y over 4 squared equals 1. Cleaning up a little more, that would be x squared over 6 squared plus y squared over 4 squared equals 1. And if you think back to a previous pre-calculus class, that is an equation for an ellipse centered at the origin. So we did indeed create a parameterization for an ellipse. And it turns out it's just a tweak of using the first parameterization we had for the unit circle, which is kind of cool. Okay, time for, oh shit, time went by too fast there. Darn it. Come on,